So this lecture is going to talk about how we protect our circuits from overloading. So specifically our parallel circuits, since those are the ones that can overload if they get too much current flowing through them. So the first one we're going to look at is safety fuses. So these guys are going to be connected in series, so they will be in a series circuit on the parallel line. And so if we go back, there we go. Here to the overload from the last lecture, you can see there it's got fuse marked right there on the diagram. So it is in this, you can see it's in series, so it's here, and if that breaks, it's actually going to shut down everything in front of it, or going forward. So let's see how these guys work. So when you've got a fuse, it's got this wire running through it, and that wire is rated for the same amperage as the wire it's working on. So if the current goes too high, so let's say it's the 20 amp wire from our circuit in the lecture before, this is a 20 amp fuse. And so this wire, if the amperage goes above 20, is made out of material that will melt above 20 amps. And it will, once it melts, it will be empty and it will stop the flow of the current. So a 20 amp fuse will blow, quote, at anything that's above 20 amps. So if it hits 20.5, that material in the circuit will melt and it will stop the electric flow. Modern buildings have circuit breakers, so you're not going to see fuses like this in a modern building, but you probably are familiar with fuses from things like your car. They're little cartridges with little metal prongs on them, and those are the same thing. They are working to protect your electronics, so if the current goes too high, they pop, and the little material that's inside of the plastic casing will have melted or exploded, depending on the type of fuse that it is, and you have to put a new one in order for that circuit to be able to work again. Modern circuit breakers, these guys have magnets in them or bimetallic strips, which we talked briefly about in the heat lectures. So bimetallic strips, those are the guys that are made out of two metals that have different expansion rates, and so they bend. And so it's the same idea. When too much current flows through, these guys open. So they are going to pull apart, and that will keep the current from flowing until you go back and reset it. So if you've ever had to flip the circuit breaker, what you're doing is either pushing that bimetallic strip back so it's back in contact, or you're flipping the magnets back and forth so that they are actually back in contact with each other for the wires to work. So the other thing that I want to talk about is a short circuit. So short circuits are interesting and dangerous. So they are what a short circuit happens when you have any sort of area in a circuit that has less electrical resistance. So for example, you can see down here, here's our voltage. So this can be the plug in the wall. And you've got an area here that has created a short circuit because the resistance is lower than where the light bulb is that you want the electricity to go to. So what's happened is it basically creates a shortcut by accident. So there's lots of ways for this to happen. One of the more common ways in a house is when the wires might get frayed, and that allows the current to jump. And the problem with the shortcut or the short circuit is that you can easily get a high amperage this way, because what happens with a regular circuit is that this resistance from the light bulb drops the current, right? It slows it down. But with a short circuit, for example here, there's no resistance. And so the current is able to flow faster and could be way more than what this wire can handle. And this can melt the wire, leading to fires. So that's short circuits happen basically when the wires are bypassing where they're normally supposed to go for their pathways.